Okay, if you guys did not finish up your circuit last class, this would be your last chance to still get full points on it. Thank you. And the book assignment, there was like 4 of you, I think, turned it in the Google Classroom. If that was not you, this is your last chance to get full points on the book assignment number 20. So make sure your name's on it, come throw it in the inbox.
I like your new clock. At least I think it's new.
Very observant.
Yes, I have my own. I know, I have my own.
I tried one the other day.
I wasn't here for the day last week. I was wondering if I could turn in the book assignment on like next class or on Google Classroom because I didn't have as much class time to work on it.
Yes, you get 1 extra day, so I need it by tomorrow. Okay. Last call. Anything else? All right. So we need to move on to the last of our big topics for Unit 2, which is going to be chain rule. Thank you. So I've been kind of telling you, or mentioning chain rule as being the last of the things that they expect you to be able to do with derivatives, except for different question types that come later, of course. But the last that kind of go by hand. So first off, it's probably important to say that if I had to pick a single unit for first semester that's the most important, it is probably chain rule. Chain rule is fairly equivalent to how important unit circle was in pre-calculus first semester. Kind of how you see it, and then you just basically use it forever after that. Same idea with chain rule. Second thing I should probably say about it is that it's not a different type of differentiation, it's an additional step. So after you do the power rule, you might do the chain rule. After you do the product and quotient rule, you might do the chain rule. After you do a substitution for one you memorize, you might do the chain rule. So it's not different, it's just one extra step that we need to consider. Okay, so our notes in 23, we'll talk about when chain rule is applicable. We'll talk about a couple quick examples, and then we'll practice some of those on 24. And then the second half of class, I've got 5 Khan Academy assignments for you. 3 of them have to do with chain rule, 2 of them do not. The 3 with chain rule, well, it doesn't matter. There's no point in telling you yet because that won't make sense just yet. Okay, so chain rule. Chain rule is needed anytime you want to take the derivative of a composite function. A composite function is when you have a function plugged into another function. So our front half of this worksheet is just me trying to show you and convince you that the chain rule is needed. So if I asked you guys to try this derivative, I suspect some, if not most of you, would do the power rule. You'd bring this 2 down, and then you'd lower the power by 1, but that is not the derivative of that. The real derivative, I'm still not talking about chain rule yet, but of course we could do x to the 3rd squared is the same thing as x to the 6th. So the real answer to this is 6x to the 5th. So with chain rule, we can do it like how I was wanting to do it on question 2, but we have to add that extra step to make it actually work. So here's what you would probably guess it to be before you hear chain rule. Here's what we know the answer to be using algebra. So when we do chain rule, you need to think of these as inner and outer. You've got an inner function being plugged into an outer function. So if I was trying to work this with chain rule, I see that x to the 3rd is being plugged into something squared. So I'll call the something squared u squared, and what's being plugged into u squared is x cubed. You have to think of inner and outer. So one of your 5 Khan Academy assignments today, this is actually one of them, just identifying what's the inner piece and what's the outer piece. Okay, and then chain rule kind of has 3 steps. I honestly don't think of this in 3 steps very often, but this is what the process is. First, you're going to take the derivative of the outer part. So that would just be still the same old power rule. Bring the power down, lower the power by 1. Except it says with the inner function plugged in. So we're not going to leave it u to the first. We're going to plug in the inner function. So that's the derivative of the outer function, power rule, with the inner function still plugged in there. I just left it alone. Next, you have to take the derivative of the inner function. So x cubed would become 3x squared. And then finally, if you take this, the derivative of the outer function with the inner function plugged in it, times this, the derivative of the inner function, you get 6x to the 5th, which again, we know that to be the answer. So you have to take the derivative of the outer part with the inner part plugged in times the derivative of the inner part. So it's really that derivative of the inner part that's kind of the extra step that kind of tag along. Okay, so that's kind of a lame example because again, you really could work this with algebra and just do power rule. So I wouldn't normally do this in chain rule. I'm just trying to pick out easy examples for you. But the next one, there's nothing that you can do with y equals e to the 4x. So you can't just rewrite this in a creative way and avoid the chain rule. Chain rule is unavoidable. So the outer part to me, I see we have e to some power. So I'm going to call this e to the u. And what's being plugged into that, the inner part, is 4x. I'm plugging 4x into e to the u to get e to the 4x. You got to identify what's being plugged into what. So step 1, take the derivative of the outer part and the derivative of, well, I'm going to start rephrasing this now. So I've been saying the derivative of e to the x is e to the x, and that's true. But now I'm going to say the derivative of e to something is going to be e to the something. Except it's supposed to be with the inner part plugged in. So don't say u, leave the inner part plugged in. Derivative of e to something is going to be e to something. But also find the derivative of the inner part. 4x is the inner part. So its derivative is 4. And when you take the derivative of the outside part times the derivative of the inside part, the whole thing makes up the true derivative. Okay, so one thing is, it doesn't mean that you've been doing derivatives wrong. In fact, if you look back at all the stuff you've been doing, e to the x really does have a derivative of e to the x. You can think of taking the derivative of the whole thing with the inside part plugged in. And it's like you're plugging in x, but what's the derivative of x? Right, and since multiplying by 1 doesn't change anything, that's why what you have been doing has been correct. They have just been rigged questions where you never had to worry about the chain rule. Okay, so over here, these are, I don't know, I typed these up if they help you, but these are the 2 examples we did on the front page. X cubed squared and y equals e to the 4x. Inner function, outer function. But this little formula, this is probably going to help you with one of your Khan Academies today. This is still chain rule. It's just with math symbols. This is saying if you want to take the derivative of a function plugged into another function, g is the inner function, f is the outer function, you're going to take the derivative. You're going to take the derivative of the, there we go. You're going to take the derivative of the outer part with the inner part plugged in times the derivative of the inner part. So just a way to say the same thing with math symbols. I think this method is pretty helpful, or this formula, if you want to call it a formula, if you're looking at a table of values. And one of your Khan Academies today will just be tables. So I would be referring to that specifically to know what you need to pull from that. Okay, so even though this is kind of the formula for it, derivative of the outer with the inner plugged in times the derivative of the inner, typically, I don't know, it doesn't really need to be quite that wordy. When I look at this, I see I've got something to the 7th power. And how do we normally take the derivative of something to the 7th power? Okay, so just use the power rule. Bring the power down, lower the power by 1. But when you're taking the derivative of the outside, make sure that you plug in the inside. That's still just power rule. I just brought the 7 down, lowered the power by 1. Then come back, and before you forget, and I'm going to try to do this, the chain rule step in a different color today on all of our things. You got to come back and you've got to multiply by the derivative of the inside. All of that makes up the derivative. So in purple to the right, I will put the chain rule step. Again, the part in red looks more complicated, but it was just power rule with a messy thing inside of it, but I didn't do anything with it. All I did was bring the 7 down, lower the power to 6, and then multiplied by the derivative of the inside. Okay, number 7. First, I would probably rewrite this. We know a cube root is like an exponent of a third. So, the derivative of the outside would say bring the power down, lower the power by 1. I'm not going to worry about simplifying it all here. And then chain rule, you need to come back and multiply by the derivative of the inside. Every single time. Honestly, what's probably the hardest part of chain rule is just training your brain to never not think about it. You have to think about it every single time you take a derivative. If you take a derivative without considering chain rule, it's already a 50-50 shot whether it's wrong. Okay, question 8. How do we take the derivative of sine something? Have we been doing that? Okay, so cosine something. If it's 2x, it's 2x. If it's x, it's x. But since there's an inside part here, 2x, chain rule says come back and multiply by the derivative of the inside. So this whole derivative is 2 cosine 2x. It's just adding one extra step, one extra derivative. Okay, and I only graded a few of your circuits. Well, actually, I looked at a bunch of them, I guess. But do you guys remember what the derivative of tangent something is? Okay, so secant squared of the something. This is the derivative of the outside with the inside plugged in. And then chain rule, we just come back and multiply by the derivative of the inside, which would be times 2x. So that in red is the chain rule step. So the chain rule derivative part is not harder. It's only going to be power rule, something you memorize, maybe product or quotient rule, very rarely. It's just a matter of remembering it. Okay, so let's slide over and let's start knocking off a few more practice questions. On 24. Okay, so I'm going to do the first several for you again. I want you to try to hear what's consistent from question to question, and then I'll start asking you guys to try a couple, and then I'll have you do the last 5 or 6 before we just check them as a group. One of your Khan Academies will be like this today, actually taking the derivative of a function. So, question 1, I see I've got something to the 4th power, so the derivative, I would do power rule. Bring the power down, lower the power by 1. Don't do anything with the inside, at least not yet. Then come back and multiply by the derivative of the inside, which would be 12x plus 7. All of that's the derivative. And of course, we do lots of multiple choice in here. Since your AP exam is multiple choice, I can promise you if this is a question on your test, one of the answers is going to be this, the test to see if you forgot to do the chain rule. It will always be one of the choices. It's the best distractor. Okay, number 2, same thing. It's t's instead of x's, but I've got something to the negative 2. So bring the power down, lower the power by 1, and then come back and multiply by the derivative of the inside. 8t minus 3. You're still encouraged to rewrite. So cube root's the same thing as an exponent of a third. So bring the power down, lower the power by 1, and then come back and multiply by the derivative of the inside. Okay, to be able to do question 4, 90% of it's going to just depend on you having this one memorized. What is the derivative of cosecant something? Okay, so negative cosecant of the something, cotangent of the something just happens to be 7w here. And then in this question, chain rule says we should multiply by what? 7. Derivative of the inside times 7. Okay, on question 5, what part of question 5 looks like the inner part to you? Maybe we just underline that. What's being plugged into something else? Okay, I agree. 3x plus tangent x, that's the inside. So your first thing is to take the derivative of the outside, which is 2 sine of something. So that would be 2 cosine of the something. Again, I'm saying something now instead of x so that we can apply it to other things. And you have to come back and not forget to multiply by the derivative of the inside, which would be 3 plus secant squared x. Okay, of the rest of the questions, I'd like you to try a couple of these, and then we'll check them and do a couple more. I'd like you to try 6, 7, and 8. We will be skipping questions 9 and 10 today, just because I haven't shown you how to take the derivative of an exponential function besides e to the x. That's why you can't do 9 yet. And I have not shown you the derivative of inverse trig functions, which is why you can't do number 10 today. But try 6, 7, and 8. We'll check them, and then I'll let you try the last couple, and we'll check them. Make sure we're all kind of got a good general idea of what we need to do for chain rule. even if you're not finished, let's go ahead and see what you should have done here. So number 6, and I want to talk about number 6 just a touch more than just going over the answer, but the derivative of tangent something, this is one that you should memorize. The derivative of tangent something is always going to be secant squared of the something, then times the derivative of the inside times 10. The one other thing I want to say about this is if you like Google searched a calculus like formula sheet, or if you looked in our front or back cover of our textbook, for those of you that checked one out, or if you just went back there and looked, it's got all the derivatives, all the integrals that you will have to memorize in this class, but it never, just so you know, it doesn't ever write the derivatives like this. It doesn't say the derivative of tan x is secant squared x. The reason it doesn't do it this way is because that's only true for x. So what they would do, if you ever look at one of those formula sheets, is they're going to say tangent u becomes secant squared u times u prime. And this is really just referring to chain rule. Make sure that you take the derivative of the inside. And all of the formulas are written in u's and u primes, so that it doesn't just work for x, it works for all things. And that's taken into account, chain rule. So, okay, the next one, the derivative of 5 would be 0. The derivative of e to something is still e to something, just like e to the x is e to the x. But in this case, your inside that you had to come back and multiply by was 4 plus 7t to the 6th. Again, I know that you can take that derivative. It's a matter of remembering when you're not prompted. And then same idea for number 8. The derivative of e to something is going to be e to the something. Just make sure that you remember to come back and multiply by the derivative of that something. The derivative of 1 minus cosine x would be positive sine x. Okay, skip 9 and 10, and then I would like you to try the last 5, please. If you aren't sure, just give it your best guess. Just another minute or two. let's see if you need to make any corrections here. And what I'll do out to the side here is I'll write out all the things that you have to have memorized to be able to do these. So the derivative of natural log of x is 1 over x. That's one we memorize. So for 11, that's how you start it off. Natural log of x is 1 over x. The natural log of this stuff is going to become 1 over this stuff. It's the exact same format as 1 over x. It's just a much fancier x this time. Times the chain rule step, which would be the derivative of the inside piece. 0 minus 10y plus 3y squared. All of that's needed for the derivative. So, same idea with number 12. Natural log of something is going to be 1 over something. In this case, the something is sine x minus cotangent x. Come back and multiply by the derivative of the inside, which would be the derivative of sine, which is cosine, minus the derivative of cotangent. And what's the derivative of cotangent?
Cosine squared.
Like that?
No, cosine.
Huh? That's not right. Right, it's negative cosecant squared. So minus a negative, this becomes a plus. All of that's your derivative. Okay, number 13 is probably my... Actually, let's come back and do 13 last. I like 13 a lot because it shows you that where you put this 6 exponent makes a big difference. Okay, but for number 14, we got to do 2 terms here, so 2 different derivatives. So this guy, we could bring the power down and lower the power by 1. But then there's an inside. The inside is 7w, so chain rule says multiply by 7. Okay, then separately, second term, the derivative of e to something is going to be e to the something still. But don't forget to multiply by the derivative of the something. So times a negative 1. Or just change this to a minus. Either way. Okay, 15 starts off easy. Just because you always have to consider chain rule doesn't mean that you always need chain rule. 3z to the 7th is no chain rule. You can bring the power down, lower the power by 1. The inside there is just z, and the derivative of z would be 1. You can multiply by 1 if you want to, but of course that's not going to change anything. Okay, minus the derivative of sine something is going to be cosine of something. And this inside does not have a derivative of 1, so you need it to multiply by 2z. That would be the derivative of the inside. Okay, and then to come back to question 13, just copy it all down here so it's a little easier to see. Okay, so the first part, the derivative of sine something is going to be cosine something times the derivative of the something, 6z to the 5th, just power rule. But then this is what concerns me. And I know you guys are used to kind of seeing the trig exponents like this if you did pre-cal last year. But this, sine of z to the 6th, is the same thing as saying the sine of z all to the 6th power. It's just with trig functions, we don't like to put this many parentheses. And if you don't put parentheses like this, it's hard to know, do you mean to raise z to the 6th power, or are you trying to raise sine of z to the 6th power? So with trig functions, we put it right there. But again, these two mean the same thing. In fact, you probably should add this to your notes because this is a challenge for some students. But if I think of it like this, I could bring the power down, lower the power by 1, and the there is an inside. The derivative of sine is cosine. Now, you don't have to do this, but you did have, I just want to make a reference here, one of the questions on your circuit last class wanted you to find the derivative of sine squared, and you didn't know chain rule at the time, so they suggested you change it to sine times sine and do the product rule. And when you did that, you ended up with 2 sine x cosine x, I believe, when you did the product rule. And there's nothing wrong with that. When the product rule works, if you prefer it, then use it. But you have to understand, sometimes the product rule is not going to work. Sometimes quotient rule is not going to work. Sometimes you're going to have to do chain rule. So now that we've seen chain rule, we could say, we could do the same thing, bring the power down, lower the power by 1, and then take the derivative of the inside. And to me, that's a lot faster than applying the product rule and then using a trig identity or two to try to make it look nicer. But just a suggestion. Okay, so again, this is typically how you see chain rule. And if you can do power rule, product rule, quotient rule, and get the ones that you're supposed to memorize, it's not any harder other than it being one extra step. Just remember to always try to take the derivative of the inside after taking the derivative of anything. Is there anything that jumps out at you about these 15 you'd want to clear up? Okay, so one of your Khan Academy assignments are questions like those. 2 others are also on chain rule. So if you guys would go ahead and get out a blank piece of paper for your scratch work here, 25. I would probably do that chain rule part last. One of the chain rules gives you a table of values. One of the chain rules just asks you to try to figure out what's outer and inner. That's probably a good one to start with. And then 2 of the others are just things we need to practice. One is on the definition of a derivative. I showed you but didn't have you practice other than like 4 in your notes. And one on estimating derivatives. So this, your own piece of paper, number 25, that's where you should do all your scratch work. But it's also a place for you to write down things at the top of your page that you get to, that you realize that you might want a reminder of before we quiz again. And
Mr. Johnson.
just a second. Yeah, what you got?
What should I identify on my computer today?
You just have to do it for homework, I guess. Sorry, I don't have any extras. You got something else you could work on to just switch it out, maybe? Something for another class that you were going to have to do at home, and then you could do this at home instead.
Yeah, I guess I could do that.
I don't know what else. I'm going to leave these tips up on the board. Again, you might want to write these on the top of your page, but one of these is about definition of a derivative. I know you have the 2 forms in your notes, but I would put them on your scratch paper too. One of these Khan Academies is just on estimating derivatives. So you can think about slope and the slope formula. And one of them is on chain rule given the table. So I would think of it like the formula chain rule, not the way we phrased it on that last handout. So as you get to those, you might use those hints on the board there. And again, I don't have any preference which order you do them in, but one of those chain rule ones is certainly a lot easier than the others, the picking the inner and the outer. And you have the rest of class to work on this, so you've got about 55 minutes, quite a bit of time. I know 5 Khan Academies, it's not the shortest, but for a whole hour, or almost a whole hour, that should be enough time to avoid having any homework. Just like we did the first couple Khan Academies, again, I tried to pick these out because some of you need to do 10 questions on estimating derivatives. Some of you might need to do 30, and trying to assign it through Khan Academy just gives us that flexibility. You can make 100 on it in 4 questions, and you must know what you're doing, and I don't want you to do 50 of them. But if you need to do 50 before it clicks, then you need to do 50 before it clicks. So. I'm going to pass back your homeworks, but of course you guys can stop me and ask for help as you get to stuff. Just like the first time we did the Khan Academies, remember if you do miss a question, you should have a little pop-up in the bottom right, and there should be a little link within that that says Get Help. If you click that, it should show you their steps. And if you compare your steps and your thought process to theirs, you can learn from your mistakes so that you don't just keep making that mistake and have to just keep trying. So, does anybody need me to come over and help yet? Okay. I will ask again here in a bit, but obviously you can ask me for help at any time. Remember, I do want you to make 100 on each of these. If you do try one a couple times and you're still not making 100, you're welcome to skip it, come back to it. Okay, it doesn't really matter to me with the order, as long as you feel like you can do these things okay.
So what's that like cosine to the 9 power?
Mm-hmm.
They are.
Mhm.
Is it?
Because you're plugging cosine into something to the 9th power.
Oh, not the other thing. That's not
Correct.
skinny. Okay.
Yeah, it's not cosine of x to the 9th.
Oh, okay.
You know what I'm saying?
Yeah. Because if it was What if the x had a 9, would it be?
Yeah, then you would be plugging x to the 9th into cosine x.
Okay.
Yeah, with those trig derivatives, a lot of times you just want to rewrite them. If it's cosine to the 9th, cosine to the 9th. So think of it as cosine to the 9th, like that. Same thing.
Okay.
For whatever reason, this is just harder for y'all to imagine than that, so.
Could you check on your computer?
Yeah.
We're gonna discussion. Yeah. Yeah. Are you in that?
Alright, I still have about 35 minutes, but I suspect you're probably starting to find some stuff maybe I can help with. So just call me over as I come around if there's something I can look at and help. are the two forms. So looking at your answer choices, does it look more like the standard definition in the top right or the alternate version below it? The one on the top has a denominator of h. So it's got to be the other one. So this is your hint. Whatever's here is supposed to be your function. So that probably narrows down a choice or two. This is supposed to be whatever your function is with the value of the derivative you want. So this could be a number, or should be a number. This a and this a should be the same. The rest is. Of course, as you guys finish up the last one of these, if you finish these up in class, then you don't have any homework. But if you don't, then I would like you to finish those before Wednesday. Get the practice in you need. But while this stuff is fresh in your head, you really should write down on the top of your scratch work anything that you struggled with. Even if it wasn't anything major, you might appreciate the reminder. Okay. Yeah, there's always one on that table. There was no best something like that. No. Okay. Want to help? Anything back there? All right. Maybe.
If I get this wrong, then yes. So I don't understand. Well, I watched the video like twice.
Okay.
And it was talking about the like change of y or the change of x.
Mm-hmm.
And is that like the same as that? Come on the video, but like just like for this one, it'd just be 3.
Okay, you're just trying to estimate derivatives, right?
Yeah.
You're trying to estimate the derivative at 2. Well, remember, derivative just means slope. So that's up here. If you think of estimating derivative with slope, and you know the slope formula, you want to know the slope at 2, the best you could do, given your information, is find the slope from 1 to 4. So subtract the y's over subtract the x's, use the slope formula. And whatever the slope is from 1 to 4, that's your best estimate for the slope of 2.
Okay. I was kind of wrong. So I don't know what's.
So negative 33 take away negative 25 would be negative 8. Okay. So we know that's the slope from 1 to 4. So without more information, we have to guess that's the slope the whole time. So then the last key is to know that derivative means slope. So we'll change it to a decimal, it should be like that.
Okay.
You're welcome to use a calculator. Just do it.
Okay. I think I just keep messing up the negatives.
Well, which one of these two does it look like? Okay, so the denominators are all h's. limit says h approaches 0. Okay, so then in the top right, you either have your function or your function with the number plugged into it.
Okay.
So is this in terms of x's or is this in terms of here's just a number? It just depends on the question. It can change. Okay, then this over here is a function with x plus h. And if they're plugging in a number here, they're probably plugging in a number there too.
So, like, I look at this is x plus h, it looks like the function was 1 over x, and then plug in 1 over x, and then plug in 1. So, if they're plugging in a 1 for x, then they need to be plugging in a 1
For x there too. So if this is 1 over x and they're doing 1, then that makes sense for that to be 1.
Well, I'm not saying it's choice A, I think it's look right. Why wouldn't it be D? Should be x plus h is 9. And then this one. You okay with that? I can't take this seriously.
Of course, if you're not finished with this at the end of class and you think you're going to need some help from me, you can sign up to come see me during advisory tomorrow. This x to the third would cancel out 3 of those. So that would just leave you with 4 in your numerator and an x in your denominator.
just didn't simplify.
All right, we're down to about 7 minutes here. So if you need to continue to practice those assignments to get 100 on all of those, then please do. The cutoff for that is at the start of class on Wednesday. So obviously I'd prefer you to do it and get it done tonight, and that way you can come see me during advisory. I guess you have to decide before then. But if you need some help, just sign up to come see me tomorrow, please. And you're welcome to keep going to the bell, but I believe today's puzzle is this one. Have y'all seen this one yet? Alright, try to figure out what's wrong with them without flipping your head upside down.
I just have one question.
What's wrong? Do you think the eyes are messed up?
Eyes are right side up.
Right side up sounds like correct. You're saying they're correct side up?
I did everything.
Okay, so the eyes, everybody sees the eyes are messed up? And the mouth? Okay, here's the flip version. Original, flip. Yeah. If you don't believe these are the same picture, just turn your head upside
That's
down.
not a math puzzle.
That's true, but I'd try to give you some variety. I can't find a math puzzle for every day.
I was like, I saw the eyes and I was like looking for like a hidden
Oh.
meaning or something.
If y'all would send me puzzles, that would help, but usually I try to find them real fast.
I don't really have an array of math puzzles at my disposal.
Well, me neither. I'd go to Google.
Oh, really?
Yeah. Friday, we're going to do a chain rule circuit and start the test review.
I won't be there for Friday.
Okay. Will you be here Tuesday? Tomorrow?
Tomorrow? Yeah.
Okay. You can swing by and pick up the handouts if you want.
I'll be here Wednesday though.
In my brain, I was thinking, I was just imagining you getting
Is that how it's listed?
You got theirs?
I slept in.
Guys did cook attendance.
Well, I'm cooked. I'm cooked. I'm happy we're gonna be going out.
Actually, buddy, you gotta wake up.
Yeah, and yeah. Coach takes texts me like, where the hell are you?
It's like the second time.
It's like the fourth time.
Fourth time.
Well, I set my alarm. I wake up like an hour after. It's like it seemed it went off. But I never heard it. Has that ever happened?
I mean, I've had